Right, Bismillah. Today lecture we're going to cover the rectangular coordinates. So the objective of this today lecture is student will be able to apply Newton's second law to determine forces and acceleration for particles in rectilinear motions. So what is rectilinear motion? Rectilinear motion is just a straight line motion without any curve, right? So this is one of the application. If a man is trying to move a 50 kilogram crate, how large a force F must be he exert to start moving the crate? So what factors influence how large this force must be to start moving the crate? If the crate starts moving, is there acceleration present? What would you have to know before you could find this answer? So for example, this guy, he tries to move this crate at with a force F at 30-degree angle from the ground, with respect to the ground. So either you can check how if with that kind of force, with that large of force, is the crate going to move? So there is some kind of factor like force that acting on the body itself. You must consider that in order to solve this problem. Right, the other application, objects that move in air or other fluid. Technically, we said fluid is either air or water or liquid itself. Right, so that's why fluid is something that moving. Is either fluid, is either liquid or air. So in this case, objects that move in air have a drag force acting on them. So drag force technically is a resistance force. This drag force is a function of velocity. So if the dragster is traveling with a known velocity and the magnitude of the opposing drag force at any instant is given as a function of velocity, how can we determine the time and distance required for dragster to come to a stop if its engine is shut off, and how to do that? Okay, the equation of motion known as F equal to ma. If you note here, F in red colored, A also in red colored, mean this is a vector, while M is a scalar in the scalar unit. So it's best used when the problem requires finding forces, especially forces perpendicular to the path, acceleration, velocities, and mass. Remember, unbalanced force cause acceleration. Okay, means that unbalanced force means that this at this part there must be a value. If this is 0, means this one also will be 0. So this one must be unbalanced. Otherwise, this the acceleration we don't have any value for acceleration. Right. Three scalar equations can be written from this vector equation. If you see here, this is vector F equal to ma. But there will be three scalar equation if we can separate that into each components. In this case, fx, fy, and fz. Okay, the equation of motion being a vector equation may be expressed in terms of three components in the Cartesian or rectangular coordinate system as in this equation. Okay, summation of force. Okay, make sure this is summation of force means that you need to consider all the external forces like friction, external forces itself. If you have a spring system, you need to consider that as well. If you have the weight, so weight is one of the force, so you need to consider that as well, and also the normal force. Okay, then if we separate that into summation of each components fx, fy, and fz, we might equal that to MA, while A itself will be separated into three components as well, MAX, MAY, and MAZ. Noted that the unit vector for each component is I for X axis, J for Y axis, and K for Z axis. Hence, to solve this equation, you need to equate the scalar equation of fx and max, like in this case, and then summation of fy equal to may and summation of fz equal to maz. Right, free body diagram, procedure for analysis. First of all, the free body diagram, if you see this equation, like discussed in the previous section, summation of f equal to ma, where summation of f here, you can show that by using the free body diagram, while a here will be used for kinetic diagram. So the same for this in this slide, you mentioned the procedure for analysis. You need to draw the free body diagram. First of all, establish your coordinate system. What is the coordinate system in this case is either which plane are you going to use for indicating the x and y direction, and draw the particles free body diagram showing only external forces. These external forces usually includes the weight, normal forces, friction forces, and applied forces. Later, show the MA vector, sometimes called the initial force, on the separate kinetic diagram. Okay, this is for MA part. Okay, make sure any friction forces act opposite to the direction of motion. If, for example, if the crate that you are going to analyze is moving towards right direction, so the friction forces must be opposite, in which it's going to point it towards left direction. So that makes sense. If the particle is connected to an elastic linear spring, a spring force equal to Ks. K means the spring's constant, while S is the changes in terms of displacement. Okay, should be included in the free body diagram. Okay, equation of motion. If the forces can be resolved directly from the free body diagram, often the case in two-dimensional problems, use the scalar form of the equation of motion. Like just what we discussed just now, if I have 2D problem, means that I might have x and y axis only. So I need to equate fx equal to max, while fy equal to may. Alright, in more complex cases, usually 3D, a Cartesian vector is written for every force, and vector analysis is often the best approach. Okay, this might be more complicated, means that you need to add another plane, which is z plane. So just equate fx equal to may, fy equal to may, while the last one fz equal to maz. Okay, this is what they mentioned just now. Three scalar equation can be written from this vector equation. You may only need two equation if the motion is in 2D. Okay, kinematic. Okay, the other procedure for analysis is about the kinematics. The second law only provides solution for forces and acceleration. Still remember the Newton's second law, summation of F equal to ma, where F is the summation of forces and ma is about the acceleration. If velocity and position have to be found, kinematics equations are used once the acceleration is found from the equation of motion. Okay, velocity here is v and position here is s. Any of the kinematics tools learned in chapter 12 may be needed to solve a problem. Make sure you use consistent positive coordinates directions as used in the equation of motion part of the problem. Okay, still remember that if you have A, how to get V, if A is given with respect to time, you need to integrate the equation of acceleration with respect to time, and then you will get v with respect to time. If you want to find the position, you need to integrate that one as well. The same, if they give you in terms of position with respect to time, you need to derive to get the velocity function of time, and also you need to derive that back to get the acceleration with respect to time. So you need to recall back what you have learned in chapter 12. Okay, this is the example for this chapter. Given the motor wins in the cable with a constant acceleration such that the 20 kilogram crate move a distance s equal to 6 meter in 3 seconds starting from rest. So they give you mu k. Mu k here is the coefficient of friction, the kinetic coefficient of friction, which is equal to 0.3. Okay, let's take a look at this diagram. We say that this is a crate A. This is 20 kilogram, and then it's kind of connected to a cable. This is connected to a motor with a cable with some inclination angle of 30 degree. Okay, how to solve that? What they ask you to find the tension developed in the cable. Okay, this is the cable, so you need to find the tension here. So technically tension is in the form of force as well. Okay, plan. First of all, you need to draw the free body diagram and kinetic diagram of the crate. Right? Then later use the kinematic equation and determine the acceleration of the crate. So you need to use the kinematic equation and then find the A. Last, apply the equation of motion to determine the cable tension. Okay, the key to solve this problem is actually based on the free body diagram and kinematics diagram. Kinetic diagram. Okay, so first, draw the free body and kinetic diagrams of the crate. Like I mentioned just before this, free body diagram is all about forces, summation of forces. But before that, you need to determine in which plane coordinate system that you want to use. In this case, if we go back to the question, this one will be x-axis, so that we can simplify with respect to the angle. So this one will be x-axis, while this one will be y-axis. Okay, we draw the free body diagram of the crate. Let's take a look at this figure. This is the crate. So we know that the crate is 20 kilogram, and we need to convert that to find the weight, because weight is one form of the force acting on the body. So means that 20 kilogram times g. G here is the gravitational acceleration, which is 9.81 meter per second square. Also, since the crate is inclined about 30 degree with respect to the ground, so we need to include the normal force as well, acting on the body, which is perpendicular 90 degree to the ground, to the plane, sorry, not the ground as well, plane, because the plane is inclined 30 degree from the ground. Okay, so we know if, let's say we take a look at this example, the motor wins, so means that you need to expect the crate is moving upwards. So once you know that the this one is moving outwards, you know there is a cable that attached to the motor. So that's why if you see in this figure, the tension developed by the cable is moving upwards because it kind of pulling the crate towards that direction. Okay, you know, once you know the direction of the crate is going upwards, so there is also mention about the mu k here. Mu k is the kinetic coefficient of friction. So it means that this plane is not smooth and it consists of friction force. So like we discussed just now, friction force is always in the opposite direction of the motion. So that's why if you see here, mu k, Fk is actually mu k times n. N here is the normal force. So means that Fk equal to 0.3 n. So n here is not the unit but is this parameter, the normal force. Okay, so finish about the free body diagram. Now you need to draw the kinetic diagrams, which is equal to the same crate that you draw here, but you need to indicate the motion direction. The direction of the motion is upwards, so means that this one will be MA. M is the mass of the crate, which is 20 kilogram times A. A is the acceleration. Okay, finish this one. Free body diagram and kinetic diagram. Now, since the motion, okay, this is the explanation. Technically, I have explained that. Since the motion is up, the incline, rotate the XY axis so the X axis aligns with the incline. Then motion occurs only in the X direction. Okay, there is a friction force acting between the surface and the crate. Why it is in the direction shown in the free body diagram? Okay, we have explained why the direction is moving downwards because this one gravitational force, so it's always pointed towards the earth. Okay, this one because of the motion itself, this is, while this one Fk will be opposite to the motion, and and N is the opposite to the inclined plane. Okay, uh, okay. Before we use we solve this problem, there is also some information mentioned. The motor winds in the cable with a constant acceleration. So here, constant acceleration is actually a key point for you to solve this problem. Okay, you know that S is actually 6 meter at 3 seconds. And the crate is moving at rest, from rest. You mentioned here, starting from rest. Huh? So it means that V naught is actually 0. So V naught is 0 meter per second. So once you know that the acceleration is constant, technically you can directly use the kinematic equation in chapter 12. Only if the motion is changing with respect to time. So you need to do some kind of derivation or not the differentiation or the integration. Okay, so technically when we know that the constant acceleration, so we can use this direct formula S equal to V naught T plus half AT square. This one you learn in chapter 12. So at 3 equal to 3 second, S is 6, V naught is starting from rest will be 0, time T is 3 second plus half A 3 second square. So solving this equation, you will get A, which is acceleration of the moving crate, is actually 1.33 meter per second square. Okay, next you need to apply the equation of motion. Okay, this is actually referring back to the free body diagram. Let's take a look at this free body diagram. Okay, if you see y direction here, in which parameter that we have that? Obviously, n direction is moving towards this direction, while the weight itself is actually in a vector form. Since we have two direction, we need to convert the wake fraction, the wake force into two fraction Fy and Wy and Wx. Okay, since so it will be negative 20 gram times cos 30. This is with respect to the plane. This one will be W, which is mg, negative mg cos 30 degree plus n. Why plus n? Because when we refer back to the free body diagram, n is positive towards that direction, while W or wake is pointing downwards of the direction. Okay, so you will get, solving this equation, you will get N, which is the neutral force, equal to 169.9 Newton. Okay, now solving for Fy. I assume that Fy direction will be positive in this direction. So, we know that, okay, what is the difference between Fy, summation of Fy and summation of Fx here? Fy, there is no motion in y direction, so summation of Fy will be 0. Whilst you know that the crate is moving in this direction, so that's why we said summation of Fy equal to ma, because the crate is having a constant acceleration in this plane. So solving for the equation of motion, the same technique, we need to refer back to the free body diagram, in which we have t here. We need to look into the x-axis direction. So we have t, which is positive in this direction, and then we have mu friction force pointing towards negative direction, and then we also have wake. If you resolve this with respect to plane, we might have negative wake towards this direction. It will be negative 20g sine 30. Here you need to match with the plane. Okay, that's why we have this equation, t minus 20g sine 30 minus 0.3 n. So this is the friction force fraction. This is the weight fraction. This is the tension. And must be equate to 20a. Why 20a? We need to refer back to this equation, ma, because we are having the motion in this direction. So m is 20a. So here you only have two. You actually you have two unknowns here, three unknowns, which is t, n, and a. But actually you have solved that a from this equation, the kinematic equation. You take a and then you just insert here a as 1.33 meter per second, and n actually you have solved that in Fy direction. So you just put 169.9 into this equation. Now you might solve for the tension T. So you solve this, you get T equal to 176 Newton. Okay. So finish this part. Okay, this is a group problem solving question. Given the 300 kilogram Barbie, okay, this is the Barbie, originally at rest, means at rest is initial velocity is 0. Is towed over a series of small roller. So there is a small roller. The motor M is drawing in the cable at a rate of V equal to 0.4 T square meter per second, where T is in seconds. What is this means? V is changing with respect to time. So it means that if T equal to 1 second, it is not the same as T equal to 2 or 3 second. It will be changed. Okay, what you need to find is the force in the cable and distance S when T equal to 5 second. So what is the plan here? Since both forces and velocity are involved, this problem requires both kinematics and the equation of motion. Okay, first you need to draw the free body and kinetic diagrams of the bar. Okay, remember free body diagram is the body with the forces acting on the body. You need to show in which direction the forces is acting on the body as well. Okay, the kinetic diagram is showing the body and its motion. In which direction is the acceleration? Okay, second, apply the equation of motion to determine the acceleration and force. Okay, you need to make sure that everything like summation of fx and summation, for example, in this case, it will be moved in x direction. So I will say that summation of fx equal to max. While summation, if there is no motion in y direction, so summation of fy equal to 0. Okay, third, using a kinematic equation, you need to determine the distance. The one that we learned in chapter 12. Okay, solution. This is the free body and kinetic diagrams of the bar. Like I said just now, the body and whatever external forces acting on the body. For example, we have the weight, in which this is 300 times g. G is the gravitational acceleration pointing downwards. Okay, remember that gravity forces is always pointing downwards. Okay, we have the normal force as well, pointing upwards. And you know that this Barbie is connected to a cable, so I have a tension here. Okay, don't forget that uh, we need to simplify that this is the axis of the body. Okay, this is the free body diagram, while this is the kinetic diagram. Kinetic diagram is showing the motion, in which this one will be 300 times A. Okay, note that the bar is moving along the x-axis. We don't have any motion in y-axis. Okay, second, you need to apply the scalar equation of motion in x direction. This is actually the same. If even we apply in y direction, I will say that summation of fy equal to 0 means that n minus w will be 0. So n is actually the same like w. But we are concerned about the motion itself. So I need to apply the summation of fx equal to ma. So in this case, we know that the direction of motion of the body will be in this direction. So I will say that this is the positive direction of the body. Summation of fx equal to 300. This is the m, the mass of the body, times a, equal to t. Okay, this is t, positive, equal to 300a. Alright, so to solve this problem, you need to find the unknowns. In this case, I would say that I know how to find A because it is given, there is information given about the velocity. So we know V equal to 0.4 t square, in which I can differentiate this equation to get the acceleration. A equal to dv over dt means that I have 0.8 t. So in this question, they ask you about t equal to 5 seconds. So we just substitute t equal to 5. I will say that I'm going to have t equal to 100 Newton when t equal to 5 seconds. Okay, now this is the advanced part in which you need to apply the kinematic equation to determine the distance. Alright, because v is not the acceleration is not constant, so it means that this is going to change. So I need to apply this technique. We know that v is ds over dt. So if we bring dt into this part, so I will have ds equal to v dt. So to find this, we need to integrate in both parts. Like this one, I know that this is my ds, while this is v dt. So take a look at ds means that this is a smaller fraction in displacement, while this is the partition of each time. So this is the limit, means that we need to refer back to what the small portion that we apply here. For example, this is ds, so I know that it will start with s naught until s, while this one will be dt. So I know that it will be start with the initial value of t 0 until t. So just integrate this. I will say that I have s minus s naught, in which I can bring s naught later to here, and then I can derive here v dt. So if I derive here, I know that v is actually 0.4 t square. I just insert here, and I find and I apply initial value as 0 because it start from rest until t. Okay, so we know that at s naught it will be 0, so s is actually 0.4 divided by 3 times t power of 3. So you just need to apply t at 5 seconds to solve this question. So you will get s equal to 16.7 meter. Okay, finish this part. So any other discussion, please let me know in our meeting later. Thank you very much.